let's just go over some of the latest stuff before we kind of get to, your main theory and the works that you've been doing and so forth. But is it really true that we're heading towards a mini ice age at this stage? And what are some of the recent development that is pointing in this direction, Robert?
Well, I certainly think that we're headed for a mini ice age. Of course, I think we're headed for the bigger ice age even. But I first came out with this book in 1997, not by fire, but by ice. And at that time, I said that we would be admitting within 20 years that we were in an ice age. Now, there's certainly a lot of people not admitting to that yet, but it was just less than 2 weeks ago, both the BBC and the Daily Mail had headlines warning of a possible mini ice age, and they have been really strong global warming proponents, or anthropogenic global warming proponents for many years. So it must have really drove them nuts to have to report that we could be headed into a mini ice age. Now, the reason, of course, for that is the decline in sunspots, and that's also what they admitted. But sunspots, those areas on the sun. Anyway, the sunspots now are a fraction of what they have been, and a fraction of what science has expected. And sunspot activity is at its lowest already in more than 100 years. Of course, that has to do with the Maunder minimum, because during the last little ice age, they had what was called the Maunder minimum, when sunspot activity pretty much declined to zero. And at that time, the ice started moving down out of the mountains, and literally millions of people died of starvation. Well, now they say that it's the lowest in 100 years, but I think it's a lot lower than that, because now we have much better telescopes than they had back. Galileo's the one that he invented the telescope back in the 1600s, and now we have much better telescopes, so we're counting a lot more sunspots than they were able to count at that time. So I think we're probably already close to the Maunder minimum level already.
Well, exactly. I mean, I think looking a little bit some of the data from the Maunder minimum, it says that Gustav Spörer was one of the ones who observed this during a 30-year period, and he said he observed fewer than 50 sunspots at that time, as opposed to more typically, it said 40,000 to 50,000. And just checking your website, I think at this time, as of January 26th, there are 3 sunspots on the sun right now.
Yes, there are. I try to update. I forget to update that some days, but I try to update that every 2 or 3 days. But yeah, sunspot activity is far lower than like NASA expected, far lower than most scientists, and yet some scientists like Theodore Landscheid had been predicting this for years and years and years. But other people say the sun isn't important. I don't know how they can say the sun is not important when it comes to our climate.
Well, it is, and it's highly suggestible that there's a 400-year kind of cycle there, and we had the last minimum ice age there about 1600 to 750, something like that, before it starts to kind of pick up a little bit again. So, how does that work, though? If you can explain that to us with the sunspot and how that interacts and changes our climate here.
Well, there's 2 parts to that, really. There's the part of the lower sunspots, but there's also a time when the sun actually goes into what they call a solar retrograde motion, and it's a time when there's 2 major planets. Now I'm trying to think, Jupiter and Saturn, but anyway. Planets are always in different areas, different quadrants of the sun. And when those 2 planets both end up in the same quadrant of the sun, which only happens about every 180 years, when those 2 pull on the sun. The sun actually has its own little mini orbit. And they pull on the sun and pull it out of its, a little bit away from its orbit. And at that time, about every 180 years, the climate on Earth becomes cooler and more extreme, so that some parts cooler and some parts more droughts. And for whatever reason, nobody really is sure of the reason, every other beat of that 180-year cycle, about every 360 years, the Earth does enter into a mini ice age. And this has got nothing to do with humans. It's got nothing to do with CO2. But this 360-year cycle matches up with the collapse of civilizations. It matches up with the collapse of the Roman Empire, of the Greek Empire, when Genghis Khan rushed out of the north, where that matched up with a little ice age cycle. The Sumerian Empire collapsed at one of these cycles. So I think these things are much more important than anybody realizes, and I wish we could be talking. I'm glad that you've called, because I wish we could be talking about it a lot more.
Yeah, exactly. I mean, it's very, very important, and well, again, who knows how this will develop and in what direction it will go if it unfolds. You know, as you're predicted, we have no idea how to deal with this situation, specifically with the technology that we have at our disposal. I mean, people, the further back in time you go, the more subsistence living you had. People were accustomed to living off the land and everything else. Today, it would be a total chaos that would set in. Unfortunately, I think
it would be total chaos in one respect, but better in another respect. Because, for instance, during the last little ice age in the United Kingdom, millions of people died of starvation. I mean, you didn't want to be thrown in jail, because sometimes you became food for the other people that were in jail. And there are written instances of parents eating their own children. It got so bad. But now we have a much better food distribution system, because back then, if you were in a small area, let's say 50 miles away from the nearest food supplies, and you got snowed in, what in the world do you want to do? But today, we have trucks, we have cars, we have airplanes, we have trains, we have boats, we have much better transportation systems, so we can bring food from longer distances. I think that will help a little. But I'm not sure how much that will help. It won't help much if all of the oil fields in the north are covered with ice.
Yeah.
Or if the coal fields in the north are covered with ice. It will help to a certain extent, but if we could start being aware of it, I think we could plan a little bit better, but I don't know how much.
Is that, by the way, something you have looked into? Let's say that we have a full-on onset, mini ice age that even then might develop into one of the big whoppers, if you will. Is there any way with the technology that we have available right now that we could resist that we could live on top of the ice in any capacity, or will we just be pushed, just further south with the ice? That would be it. We couldn't resist this thing at all.
I remember one time I was doing a radio interview with a radio station in Canada, and some guy called in and he said that he lived in a trailer or a mobile home, and he was just going to start jacking it up to be above the ice.
Right.
And I'm figuring he's going to have jacks that are a mile long,
right?
Because
right.
some areas of Canada were covered with even 2 miles thick of ice. So, no, I don't know that our technology would help us all that much at all.
Yeah, it's very discouraging. So, what happened here with the recent the polar vortex, or what now has been dubbed the 2014 North American cold wave? What drove that, and is that indicative of something that's going to come and every year and going to get worse and worse, or is this just a one-off?
Well, who is it? Piers Corbyn. He's an astrophysicist in the United Kingdom, and he's been saying that we're headed into a little ice age. So there's astrophysicists who have been saying this, or for instance, also Dr. Habibullah Abdusanatov, who's an astrophysicist in Russia. And he's not just any astrophysicist, as if that were not enough by itself, but he also happens to be head of the Russian part of the International Space Station. I mean, so this guy is, talk about being legitimate, and he has been saying for years that we're headed into a little ice age. And now I've forgotten the other half of your question. I'm sorry.
Yeah, no worries about that. Exactly. Basically, what drove this thing, and if it's something that's going to keep on recurring and getting worse and worse as we go each season, each winter.
Well, okay. Now that reminds me, the sunspots, and this is why I mentioned Piers Corbin. Is he said that this change in the sunspots and the decline in activity, it will change the jet stream, and so I've been hearing it called a polar vortex, but really I'm just looking at it's the change in the jet stream that is moving this cold air further south. And in this case, I'll have to talk about the United States, but I have a map on my website on iceagenow.info, but down on the right-hand side of the page, of the first page, I have an ice age map that shows where the ice extended to in the North American continent during the last ice age. And when I look at the maps of where this jet stream is now taking the cold, sometimes they match up almost exactly with that map that I have there on the page. So it would just look to me like that jet stream is really what controls where the snow goes. Now, with that said, the United States right now is having record cold temperatures. They're looking during the next week the temperature is going to be 20 to 40 degrees below average. It doesn't really take that much. One of the things I keep saying is it does not have to be all that much colder to have an ice age. During the last ice age, on average, in the world, temperatures were only about 5 degrees colder than they are right now.
Wow!
So when we're looking at temperatures 20 degrees, 40 degrees below average, we're way past the idea of an ice age. An ice age isn't necessarily all that much colder. It just gets more precipitation in the winter.
Right.
And that precipitation, it falls as snow, and then the winters last a little bit longer, and then they come back a little bit earlier in the year. But it's that snow that doesn't melt, and it's also snow blitzes, so that you have times when the huge amounts of snow fall in just a couple or 3 days. So it's not like glaciers come grinding out of the north.
Right.
It's that we get more and more snow. So the temperatures, right now in the United States that are so low, yeah, I think that's important. But what I think it's even more important that we watch in Sweden and the United Kingdom, wherever we are, is they watch the amount of snow that's starting to fall.
Exactly. Yeah.
And the precipitation. For instance, during the last little ice age, and it sounds like you know a lot about that, but during the last little ice age in Great Britain, for example, the rainy season lasted for about 5 weeks longer in the spring, so the farmers couldn't really plant their fields. And then the rainy season came back a few weeks earlier in the fall, so they weren't able to harvest those fields. That's where the big problem still lies. I keep on going back to food. I'm worried about food.
Yeah, exactly, because that would be much more difficult to farm. Obviously, wouldn't be enough to go around, and it would be all those things that we're accustomed to it's not something we could keep up. And the question there then, of course, is, all right, is there any technology greenhouse-wise that we could actually utilize and still do some growing? I mean, if you look at how things are in Alaska or northern Scandinavia and stuff like that, there is a season there, but you're stuck to that. It doesn't matter what you do. Sure, you can heat up, have a heated, greenhouse and stuff like that. But it doesn't do that much really. When the winter sets in, that's it, right?
Right. Well, but if we could have, for instance, you mentioned Alaska. During the last ice age, really not much of Alaska was covered. Canada was covered by 1 to 2 miles of ice, but Alaska remained a lot like it is today because the Pacific currents were keeping the warmth there. So there are certainly areas in the world where greenhouses would be like gold, or even United Kingdom. I mean, where they're going to get more rain, but they're not going to necessarily get all that much more snow. So well, they will eventually. I mean, during the last ice age, eventually there were polar bears roaming the outskirts of London. So that would happen eventually. But no, I think we're talking about moving south. Unfortunately, for a lot of people, that's probably going to be the savior. But again, I think there will be wars, as there were during other ice ages, many ice ages. That there will be wars over food. There will be wars over water, and somebody who wants to move south is going to find out that southern country is going to close their borders to them. So. A lot of things like that will be out of our hands.
Interesting. Yeah, exactly. Would be a reversal of what we have seen, but the North has been good in opening up their borders, so I hope they will return that favor once that happens.
Yes, yeah, yeah, because I think, for instance, United States, a lot of people will be wanting to move to Mexico.
Right.
I don't think they have to go that far south, by the way. All you have to really do is look at the maps of previous ice ages and see how far south the ice extended, and then just try to get south of there. I know in the United States, for instance, the ice moved down out of Canada into the northern part of the United States, but the ice essentially followed the Missouri River. And on the north side of that river, as near as scientists can tell, there was a cliff of ice about 15 stories tall. But on the south side of the river, people could have lived there. And that's possible today. Many years ago, I lived in Juneau, Alaska, about a quarter mile in front of the Mendenhall Glacier. So there's that glacier that I could walk to from where I was living, and yet temperatures in Juneau at that time were really not bad at all. It's amazing. You can live near a glacier.
Yeah, and as you say, it's that once the seasons are still there, it's just that it gets longer and longer, and then due to the precipitation, you have the buildup of the glaciers. So, but another component to this, though, is what you mentioned in terms of the change of the jet stream. That could do potential major damage or change, if you will, the climate in a massive way. I mean, for example, imagine the Pacific currents turning, or the Gulf Stream basically shutting down, as they've been talking about for a while now. That would drastically change that, though, if something like that happened, right?
It would, and I'm not, couple 3 years ago or whatever, they had that BP oil spill in the Gulf of Mexico. They were talking about that shutting down the Gulf Stream,
right?
The part that goes to your area. I don't think that had anything to do with it, but yes, if that Gulf Stream takes temperatures, takes warm water from the south up to your area essentially, and if that shuts down, then yes, all of Europe is going to be very cold very quickly. And of course, I mentioned earlier that that at one time polar bears were roaming the outskirts of London. So it happens. There's a cycle there, and it keeps on coming back.
Exactly. Now I remember there's a Norwegian port, Narvik, it's called. It's way up there. Not the most northern tip, but it's pretty good. Distance up there, and the waters there never freeze because of the Gulf Stream. It's amazing how that just pushes its way all the way up north of the British Isles and all the way up to northwestern Norway, really, which is in one of these canals where they still can do, you can have ice-free conditions right up there because of the Gulf Stream. But if you go further south, for example, between Sweden and Finland to the Baltic Ocean, the Gulf of Bothnia right there, that tends to freeze over quite regularly. So that shows the power of the Gulf Stream,
Yes. Now I understand the Baltic Sea is a lot of it is ice covered right now. When you mentioned that, though, you mentioned those seas, and I want to mention something. Is during the last ice age, the Arctic Ocean, and this has confused scientists for a lot, because even though most of Canada was covered by 1 to 2 miles thick of ice, the Arctic Ocean remained, it didn't have any more ice than it does today. And that has confused scientists, but I think that is because of underwater volcanic activity.
Right.
Because the Arctic Ocean does have lots of underwater volcanoes. There's the primary one I think of is known as the Gackel Ridge. The Gackel Ridge is an underwater mountain chain that is bigger than the Alps. It runs for 1,100 miles long. I'm sorry, I don't know how to quickly convert that to kilometers. But
That's okay.
It's 1,100. It's 1,100 miles long underwater. Some of those underwater mountains are up to 3 miles high, and they are very active volcanically. The Max Planck Institute, and this was maybe 5 years ago, but they weren't sure how much volcanic activity there was there. They decided they'd check, and when they sent their submersibles down, some of those volcanoes underwater so active that they started to melt some of their equipment. So that, I believe, is what kept the Arctic relatively ice-free during the last ice age. And then, of course, around the world during the last ice age, volcanic activity picked up dramatically. And that's above water volcanic activity. Well, underwater volcanic activity is far more important than above water. So one of my main theories here in my book and what I talk about is that what I see is that the underwater volcanoes heat the oceans and also heated the Arctic Ocean. And so you've got the oceans heating and pumping more and more moisture into the sky. Well, that moisture rises into a sky that has been cooled down by the above water volcanoes, and that is your recipe for disaster.
Huh.
That's what I see. That's what I see happening. You know, when I started researching to write Not by Fire but by Ice, scientists thought there were like 10,000 underwater volcanoes in the entire world. That was their strong belief. That's what everything showed. Well, then in 1993, they by accident found another 1,100 underwater volcanoes off the coast of Easter Island. And these things are pumping lava into the sea that's more than 2,000 degrees hot. So they increased the world supply of underwater volcanoes by 10% in just a matter of months. Well, now, NASA now believes that there could be as many as 3 million underwater volcanoes.
Wow.
So in just 22 years, we've gone from believing there were 10,000 underwater volcanoes to now believing that there are 3 million. Now, they're not all active at one time by any means, but with 3 million of those, well, in Hawaii, they've been having lava pour into the sea from Kilauea volcano, pouring into the sea daily for more than 20 years. And when you see videos of that, you realize that stuff is boiling the water. So that is what I see as the big problem, leaving out the sunspots, leaving out the cycle. But I think this little ice age cycle, that it somehow, and the bigger ice age cycle, somehow increases volcanic activity both above water and below. And that is where, that's what we got to be watching.
And any idea of what drives that then? Because I would imagine it would be by the time we had a lot of ice on top of the poles, the north and south would basically, it would be so heavy as well for the Earth that it would literally compress. It would turn into an oval more than a sphere, right? And that in itself would put tremendous pressure on the tectonic plates and everything. And Is that what triggers potentially volcanoes? But no, you're mentioning this is before it gets to that stage even, right? So what triggers it?
Well, you are right. The during ice ages, the Earth does become very, very slightly. I think the word is oblated or something like that. But it does get compressed a little tiny bit. And of course, the oceans cover 71% of the Earth's surface. And by the way, when this happens, you've got the ice growing thicker in the north and the south, but you've also got the oceans growing shallower. I hear all this yelling about the ocean levels rising. No, they're going to fall. During the last ice age, sea levels were something like 470 feet lower than they are today. It is amazing. For instance, between Russia and Alaska, I can't think of the strait there right now, but it'll come to me. But
Bering Strait.
The Bering Strait. Very good. Yes, thank you. That during the last ice, the Bering Strait's only about 270 feet deep. So during the last ice age, with all of the ice and snow accumulating in the north and south, of course, that moisture had to come from somewhere, and it came from the oceans. So during the last ice age, the Bering Strait was actually above water.
Yeah.
And so our ancestors in the United States, our ancestors could have walked to the United States. There was a land bridge, and it's kind of misleading. They call it a land bridge between Russia and Alaska, but actually sea levels were so low that Alaska, the state of Alaska, was twice as big as it is now.
Yeah.
And on the United States East Coast, for instance, the shoreline was 100 miles further east than it is now. If you'd have been in the state of Florida, for instance, was more than twice as big as it is now. And off the coast of New Jersey, you could have gone out 100 miles and you still would have found mammoths eating grass 100 miles further east than they can now. It's amazing the differences. So yes, when you're talking about that, the weight builds up on the north and south, and then there's less weight in the center of the Earth where all of the sea levels are lower.
Yeah, that's amazing. I mean, think about all those sites that are underwater. I mean, it's clear that there's been civilization way further down into what today is the ocean. I mean, the land bridges is correct, as you say. In the same thing in the UK, England was connected to the European continent. Forget what actually that was called. There was another between Denmark and Sweden, Dogger Island or Doggersbanka, which is it's happening all over the place. So this is something that potentially would revert back then, if you will. It would be the precipitation would lead to buildup of the water in the form of glaciers, which would remove slowly water from the oceans, and once again revealing these sites, basically, right?
Absolutely, and in 2000, I think it was 2011, 2012, both of those years, even with all of the talk about rising oceans, sea levels actually declined in those 2 years, and that is from satellite measurements. I have it somewhere on my website. I don't remember where it is now, but during those 2 years, the sea levels actually declined by 6 or 7 millimeters per year. Not very much, but it's totally opposite of what the global warming proponents have been advocating. So, to me, that was another indication. I just look at all of the physical stuff that's going on. That's another indication to me that we're looking at an ice age. And around the world, we've been having, the United States this year is having record snow, but last year, I think many parts of Europe had record snow. There were parts of Romania where the snow was up to the tops of the chimneys of the houses. I mean, my gosh. We shouldn't be ignoring that sort of thing.
No, indeed. I mean, and leading on from that as well, I think it was just a few days ago now, there was the Stephen Goddard released some new numbers as to how they've been trying to push the temperatures further up to prove that it's continuing to warming, right?
Yes, absolutely. Yeah, Stephen Goddard showed, and he went back for I guess 100 years, but he discovered that NASA and NOAA and I guess probably Hat Crude in United Kingdom, but all of these scientific institutions, they have been homogenizing the actual record and the actual data and adding a degree. So if you took, they call it adjusting, but if you took away their so-called adjustments and just looked at the actual data, you would see that during the last 90 years there's been a cooling trend. I think this is almost criminal, that we're preparing for global warming when we should be preparing for the other direction.
Right. Yeah. Well, this is what they did in the 70s, though, right? They warned people of a new cooling, and then it got warming again, and now they're going in the opposite direction. But who knows? Soon enough, they'll flip back to cooling, and no one will remember. They'll go in the memory hole, right?
No, whoever is in charge politically gets to rewrite the history. So
that's right.
They can
exactly.
change it, and that's what part of what they've been doing is for instance in the 1930s the United States had what's called the Dust Bowl. The 1930s were the warmest on record. They're warmer. It was warmer then than it has been during the last 20 or 30 years, but slowly they've been removing that from the record. And then there was a big chance that there was something called the medieval warm period back in like the 1200s when it was warmer than it is today. And scientists, where they can, have been trying to remove that from the record so that they can show that it's actually warmer now than it was then. Is not true. Down on the right-hand side of my webpage, again, I've got a graph. It shows warmer than today during most of the last 10,000 years. And I would invite people to look at that. I'm going to click on it right now just so I can just mention it. But during the last 10,000 years, I think that the temperatures have been warmer than today for more than 9,000 of those years. So, we're being told it's global warming. We're being warned, and that comes from Dr. Don Easterbrook. He's a professor of geology at Western Washington University in Bellingham, Washington. And he's been studying this for years and years and years. But anyway, he's looking at that during the last 10,000 years, at least 9,000 of those years have been warmer than they are today. So when I hear people screaming about global warming, it just drives me nuts.
Yeah, I understand. Yeah.
There was a period, I agree, during from about 1980 to about 1998, it did warm, but I don't think it had anything whatsoever to do with humans. And now it's cooling, and I don't think this has anything to do with humans either. I think we're being grandiose if we think that we can affect the weather.
Yeah, I know. It's very interesting. You mentioned that this is, borderline, criminal to go against the grain in this way in terms of what we're actually seeing going on with the numbers. But there's a couple of other things that ties into this, of course, with the whole global warming debate. You have, on top of that, you have cap and trade. There are political incentives. There are, ideas about reforming economics and industry lying, behind this as well. So where is this leading, and how long do you think they'll be able to keep up that charade before people really realize that, wait a minute, it's actually getting cooler? What is going on here?
Well, I thought that would happen more quickly. Since I came out with this book, not by fire, but by ice, talking about an ice age coming, I have not had to change my story. But the global warming proponents have had to, and so then they started to call it climate disruption, and now they're calling it climate change. And now I'm hearing them say that, it's because the Arctic is getting warmer, that all of that cold from the Arctic is now moving down the United States. I don't understand the twisted logic, but I know that when I talk to someone who believes in global warming, I don't seem to get very far. There's like a religious component to it,
Right.
and it's kind of like arguing with someone about religion. Forget it. I mean, I don't argue with people about religion because they believe what they believe, and there are people in my own family that don't necessarily think I'm right. You know?
Sure.
So there are definitely scientists out there who totally agree with me, but I I don't know. You know, it could be that as this continues, that it'll morph over into people saying, "Oh yeah, it's just climate change and it's caused by humans."
Yeah.
It wouldn't surprise me if that happens, unfortunately.
What would you say? We hear all the time that it's, among the respected scientists, there's more or less consensus about what is going on. But I mean, there's a lot of critics to this, a lot of people, and those who are there being silenced. We've seen them pushed out of the media or losing their place in, as a scientific advisor to, certain media outlets, as happened in the UK and such. But is there such a thing as consensus? And if not, is it a 50-50 at this stage between the scientists, or is it possible to put a number on that?
No, I don't think there is a consensus. What was it, a few years ago, 31,000 scientists signed a petition saying they didn't think that, and these were PhDs, and anyway, 31,000 scientists signed a petition saying no, they did not think that this was happening. I've been on the radio, done an interview with Dr. Tim Ball. He was a climatologist at the University of Winnipeg in Canada for 30 years,
yeah.
And he taught climatology, and he absolutely does not, he just calls it the biggest hoax in the world. I've been on the radio, done an interview with meteorologist Joe DeLeo, who's been a meteorologist for more than 30 years. Joe DeLeo actually, for many of those years, was a teacher of meteorology at Lyndon State College in Vermont, and he taught many of today's meteorologists. I have many TV station meteorologists who agree with me, but yeah, they can lose their jobs. You know, the state climatologist for the state of Oregon, the United States, came out and said that he did not believe in it. He got fired. The state climatologist for the state of Washington came out saying he didn't believe in it. He got fired. The state climatologist for the state of Virginia, Patrick Michaels, came out saying he didn't believe in it. He got fired. And you know, if I'm a young scientist and I see my boss get fired, what do you think I'm going to do? I've got kids that I got to put through college. I've got car payments to make. I've got, so I'm not saying they're all bad. They just see the handwriting on the wall, and to me, it's all politically motivated. It has nothing to do with science, or almost nothing to do. But I mean, we all got a survival institute. We all want to survive, and if I see my boss getting fired, I'm probably going to shut up.
Well, at some point they need to speak out for what they actually see is going on, what they see in the numbers and their scientific conclusions. Otherwise, again, I think collectively later on we'll have to take a bigger hit. We have to face what's going on right now. Otherwise, if we delay and ignore, it's for most people. Then this is just going to be dropped like a stone over their head. That's going to be it. And it might even be too late at that point when they realize what's going on.
Yeah, one of the things that I recommend to people, I'll say it again now, is stockpile food. Because when it comes, you're not going to have time to do anything about it. So, and I do not sell food on my website.
Sure.
So I'm not saying that for me, but
right.
But I do have food there that because if this does happen, to me, there's going to be fighting on the streets for food long before we're covered with ice. And just to protect yourself, I would say to have a food supply hidden, and don't tell your neighbors that you have it. So that's a big thing that I'm really a strong proponent of.
Interesting. Well, that's going to get you some red ice right there, people. Interesting. But nonetheless, you had a story on your website as well a couple of days ago, or just a few actually, about the EPA, the Environmental Protection Agency, and their agenda and everything. Again, as I said, there's things going on top of this politically as well, as a way to to reform the industry and everything else. And I don't know how far you would go with that to talk about it, again, having this as a conspiracy, but it seems to me that they're taking the opportunity to push, the Western world in the opposite direction in terms of what they're telling them is going on with the climate. And then they're asking, us to shut down, industry and think about all the carbon, footprints and outlets and everything else. While at the same time, and I'm not saying, and we've talked with others about this as well, I'm not saying that humans could reverse the climate if we pumped out as much carbon dioxide as we possibly could. I mean, we as you said, I don't think we shouldn't put ourselves on that high horse. I think we're far too insignificant for that. But nonetheless, it shows that it's taking the economy in one direction, and then they're giving us a lie about the climate. So all this is this a conspiracy? Do you think to shut down industry and everything, and they're on top of it making money for themselves through cap and trade and such? Or how do you see this?
Well, part of it is, I don't know if it's conspiracy. They're following, well, yeah, I guess part of it's conspiracy, but they're following President Obama's lead. President Obama has said, and I have a video on the website of him saying this, but he says he wants to shut down the coal industry essentially, and he says that because of that electricity prices will, in his words, necessarily skyrocket. But the article you're talking about the EPA, yeah, I'll quote just from it here just for a second. The president's policies are not about carbon. They are not about coal. And they are not even about energy and the environment. They are about fundamental.
Very good. Now, to lead over a little bit to the topic of magnetic reversal, I think we could begin to just mention and talk a little bit about some of the developments here from NASA recently that they've said. That's actually a couple of months ago now, and I haven't seen the flip, but they talked about the magnetic poles flipping on the sun. What can you say about that? And does that, the 11-year cycle as we know of it, has anything to do with the ups and downs of climate, or is that just independent of all that?
There's still a lot of study going on that. Yes, the magnetic poles on the sun, on average, reverse about every 11 years, on average, but sometimes it's quicker, sometimes it's slower. And this time I think that the North Pole, or the South Pole moved, or anyway, both poles of the sun are on the same side of the sun at the present time. It's just weird as the devil. And nobody really understands why. NASA has been watching that. They don't necessarily think that it's a problem. I just don't think anybody can quite answer that. But it's not totally unusual. Let's put it that way. Whereas the magnetic reversal on the Earth, I think, can be devastating. Now, a lot of scientists say, no, that's not a big deal. And then you'll read in a lot of places where oh, by the way, just last year, the BBC, this was last January, the BBC, the British Geological Society, rather, admitted that we may be headed for magnetic reversals right now. Mm-hmm. So that was very validating for me. But when I was researching for Not by Fire but by Ice, I discovered that the more major ice ages seem to align with magnetic reversals on the Earth. And when I say magnetic reversal, I'm talking about a time where the North Pole moves to Antarctica and the South Pole moves up to the Arctic. Not that the Earth turns upside down, but just that the magnetic pole moves. Now, a lot of articles that I read, even today, say that the magnetic reversals only occur every few 100,000 years. And I mean, a lot of them say that. Probably, if you wanted to look for a consensus, that would be a consensus. Mm-hmm. But I've discovered a cycle to magnetic reversals that actually matches the Ice Age cycle. The major one of about every 11,500 years. There was the Gothenburg magnetic reversal, and I think that's probably named after Gothenburg, Sweden.
That's right.
But the Gothenburg magnetic reversal was 11,500 years ago. Then there was the Mono Lake magnetic reversal about 23,000 years ago. And by the way, 11,500 years ago, we entered a catastrophic ice age. That's when the mammoths went extinct, the mastodons went extinct, the saber-toothed tiger, the short-faced bear, so many animals went extinct. 23,000 years ago at the Mono Lake magnetic reversal, we descended into a catastrophic ice age. That's when the European elephant went extinct. The mammoths almost went extinct. 33,500 years ago, we had the Lake Mungo magnetic reversal. That's when the Neanderthal went extinct, approximately. And we entered into a short but vicious ice age. And then about 45,000 years ago, there's something called the Lechamp magnetic reversal, and we entered a catastrophic ice age. Going back further, 130,000 years ago, there was a magnetic reversal, and we came out of a ice age and entered what's called the Eocene period, which was a period of warmth even warmer than today. And then 115,000 years ago, we had the Blake magnetic reversal, and we descended into catastrophic glaciation in less than 20 years. And we did that from temperatures that were warmer than today. So I just see that magnetic reversals matching up with the Ice Age cycle. And by the way, that 11,500 year cycle, that in addition to the mini Ice Age, but that 11,500 year cycle is due right now.
Interesting. And that number has certainly come up in other talks as well with some of the other people we interviewed, 11,500 years in terms of, basically the catastrophic cycles that do occur in that way. So very, very interesting. So what drives that then? And how does it affect us here in terms of, today, again, just to separate that would be tremendously more difficult because of the technology, the electricity and everything else. But how did it affect when these things weren't around? What triggered it?
As near as I can tell, it's something called precession of the equinoxes. And when you look that up in the encyclopedia, precession of the equinoxes, they make it sound so complicated, your eyes will cross and you won't know what in the world they're talking about. So let's see if I can make it simple. Is what precession of the equinoxes means is if you could put a stick all the way through the Earth's axis of rotation and have it just extend out into the heavens, our axis of rotation is not perfectly north and south. Is our axis of rotation, we're tilted from true north and south, we're tilted like 23.5 degrees. But the thing is that axis of rotation slowly revolves. So that right now, that stick that sticks all the way through the Earth, that stick would point at the star Polaris, the North Star. But our axis of rotation slowly revolves. It takes about 25,800 years to make the full revolution from pointing at the star Polaris and back again. So about 11,500 years from now, that will point toward the star Vega, and then it moves back and it points to the star Polaris again. Now, that's a 25,800 year cycle, but because the solar system itself also revolves, then in relation to the solar system, it's about 23,000 years. And for whatever reason, ice ages seem to occur at at half of that cycle. So every 11,500 years, half of that major cycle, we do have ice ages. I think somehow, and I don't know what it is, I have no idea, but that somehow our Earth at some point gets aligned with the sun in some way, that all of a sudden it triggers that the magnetic reversal. Now, again, when you read other articles about this, they'll say that it takes 5,000 years for a magnetic reversal to occur. And yet I have seen studies that show that magnetic reversal could have occurred in as little as 30 days. And the reason I say that, there were scientists in California, Michael Prevost, and I don't remember the names of the others, but they did a study in Steens Mountain, Oregon. And what they do in order to see when a magnetic reversal might have occurred, they drill holes into lava. Because lava, when it comes out of the ground, is so hot that it does not have a magnetic field. Then as it cools down below what's called the Curie temperature, it takes on the magnetic field of the day. So by drilling into these ancient lava flows and then putting a compass down there, and I'm simplifying it, but by doing that, they can put their compass down there and they can see which way was north at the time that lava cooled down. Well, in Steens Mountain, Oregon, they drilled holes at the outside edge of the lava flow, and their compasses pointed in one direction. Then when they drilled holes into the center of the lava flow, they realized that their compass were pointing in the opposite direction. So they calculated the amount of time, and they had to guess, but they calculated the amount of difference in time that it would have taken for the lava flow on the edge to have cooled down, as opposed to the lava flow in the middle of the field. And they believe that a magnetic reversal could occur in as little as 30 days. Now, when that's happening, you cannot have, anybody with electronics background will know this, you cannot have a magnetic field unless you have an electric field. They go hand in hand.
Yeah.
And so I'm thinking that as our magnetic field, because previous times they've seen that the magnetic field has moved south a little bit, then moves back north, and moves south, so it fluctuates. And I'm thinking during that time of fluctuation that we've got electric forces moving throughout the Earth that are triggering ever more volcanic activity, and at the same time, by the way, as our magnetic field is reversing, our magnetic field protects us from cosmic rays.
Yeah.
So as our magnetic field is reversing, we lose that protection temporarily, and at that time, all of these mutation-causing cosmic rays just rain onto our planet, and I see no choice. But if you've got mutation-causing cosmic rays pouring onto the planet, then you're going to have mutations. That, I think, is the true origin of species. So I'm kind of going against Charles Darwin here. And, Charles Darwin said that evolution occurs over millions of years. And yet I find that evolution takes giant leaps.
Yes.
And I'm thinking these giant leaps occur at magnetic reversals.
Interesting. We could talk a little bit more about the correlations there, but you're right. I mean, obviously, anyone who looks at the record of how species show up and disappear, it's, practically overnight in some instances, and just explosions of species, or the death, what is the six major extinction events, or is it 5 so far? And they're looking at the 6th one basically ongoing right now, or something like that. But that implies a catastrophic change, something that dramatically changes the circumstances. So animals, other species, they can't survive anymore, right?
Right. Well, I have one chapter in the book Magnetic Reversals and Evolutionary Leaps. I have one chapter called Suddenly, because there are so many instances when magnetic reversals did occur suddenly. There's Stephen Jay Gould of Harvard University, the late Stephen Jay Gould, but he talks about how new species have occurred suddenly. And so many paleontologists, as they study, they find that those that species did occur, that change did occur suddenly. So that's a big part of it. If they did occur suddenly, what in the world caused it? Well, it had to be mutations. So what in the world caused those mutations? Well, it had to be, or it certainly could have been the magnetic reversal, and when we lost that protection of our magnetic field protecting us from those cosmic rays, then there we go. So that's what I'm looking at.
Interesting. Yeah, punctuated equilibrium. You get a jumps.
Exactly. That's exactly. That's the name of Stephen Jay Gould's part. He and I can't think of the first name, but he and Eldridge wrote a paper called Punctuated Equilibrium.
Yeah.
And that's exactly what I'm talking about. I agree with them totally.
Yeah. Yeah.
There's one place where he talks about where Stephen J. No, this is Robert J. Backer from Colorado. But he said, sifting through a 250-foot layer of the Morrison Formation at Como Bluff, Wyoming, Backer dug through strata representing well over 1 million years. He followed Brontosaurus through hundreds of thousands of breeding cycles and through major climatic changes. There was absolutely no evidence for continuous evolutionary change, said Bacher. They just sat there twiddling their evolutionary thumbs. I love that, twiddling their evolutionary thumbs. But anyway, paleontologists are the ones that really, the ones that dig into the earth and look at the actual geologic record. I'd say, again, if you want to talk about consensus, but I'd say most paleontologists do agree that evolution occurs in leaps.
Yeah, yeah, I don't doubt that. It's just indicative of what we see in the record so far. That's kind of how you can piece this together. So, just another note there on the terms of the magnetic and the electronic, correlation of the field there. Basically, what I've understood from it is that basically you get current flows in one direction, and if we had a magnetic reversal, it would start flowing in the opposite direction, which basically would fry all the electronic devices we have. Is that a fair breakdown of the situation we're facing?
I think it probably would. But another thing too, by the way, and I'm probably alone on this one, but when I was researching for the first book, for Not by Fire but by Ice, for some reason the animals in fresh water were much more protected than the animals in the ocean. In the oceans, sea dwellers, I think something like 78, 80% of the sea dwellers went extinct. But the animals that lived in fresh water, only about 20% of them went extinct. Hmm. And I think it has, and again, I'm on my own on this one. I'm hanging out there, but I think that during the magnetic reversal, when the amount of electricity the electrotelluric currents start running through the earth more, they also run through the oceans. And seawater is a much better conductor of electricity than freshwater.
Yeah.
And so I'm thinking that a lot of those animals probably got they probably got electrocuted. But again, this is one where I'm hanging out there, and I'll admit it. But
right.
That's part of what I think happened.
Well, that's interesting. How would species adapt to those circumstances, like right away? It's very bizarre when you think about it. I mean, again, there could be inherent protections in certain species. It hasn't been found out yet in that regard, but it seems if conditions change so drastically and radically, it's amazing anything survives those conditions, right?
I would say so, yeah. Now, one of the things, the evolutionary the evolution theories are saying that animals they have adapted to match the circumstances, and so they've evolved over time. But I think it works differently. I think that during magnetic reversals and these mutations, I think that probably thousands, if not millions, of new kind of species are all of a sudden created in the womb, but most of them are probably unworkable. And so, did giraffes develop their long necks in order to eat the leaves on trees, or once they were given those long necks by a magnetic reversal and by a mutation, once they were given those long necks, did they then decide to eat the leaves on long trees? To eat the leaves on trees, because that's what they had. So I think that the animals who were able to adapt to the new bodies that they were given, they were able to survive. But the animals that didn't adapt, then they died. There was a writer back in the 1940s, Goldschmidt, who wrote about what good is half of a jaw, what good is half an eye. But what he was saying is that he didn't blame it on magnetic reversals. I don't think anybody knew about magnetic reversals back then. But he said that he thought that evolution came from something creating thousands of millions of hopeful monsters. And those hopeful monsters that were able to somehow figure out how to live with what they were given, that they are the ones that survived. And I go along with Goldschmidt in that regard. I think that rather than between magnetic reversals during that 11,500 years between magnetic reversals, yes, I do think that evolution probably helps a little bit. For instance, in the United Kingdom during the heavy coal mining days, there were moths that suddenly, some moths by mutation became black, and they were able to hide better on the coal. So for a while, those black moths were really advancing. And so in that respect, yes, I think evolution works. But then every 11,500 years, I think we are looking at major jumps because of mutation.
Yeah, I mean, I think what seems to be difficult to prove is the macro evolution. I mean, you have microevolution for sure, improvements within the species, and they, change subtly, but you don't have, what we don't see is one species turning into another type of species, right? So that's the crux in the situation. And so what you're saying, I guess, is that there would be maybe a number of, because when we think of mutation, we think of maybe radiation damage and weird, bizarre, strange things kind of occurring. But what you're saying is there might be a situation where you have a set of those species around that have gone through these mutations, but they haven't survived in the long run because with what they were given, they still couldn't adapt to the circumstances. So it's just a few that kind of pass that threshold, if you will. Would that be a fair assessment?
I think so, and we still, even with all of the mutation and all the changes, giraffes have the same number of bones in their neck as we do. Bats still have fingers, Whales they find from 50 million years ago. Once in a while, they'll pull up a whale because whales used to walk on land. Once in a while, even today, fishermen will pull up a whale that has an ancient, a throwback, and will have hip joints growing out of its rear end. So some of those things still, we still see that happening today. Still today, you'll see calves born with 5 legs, and of course they don't survive. But horses, for instance. I mean, horses, they have 5 toes like we do, except one of their toes is a hoof. But we're all built on the same basic framework. It's just elongated. I mean, there was the Triceratops that had 3 horns, and there were other and I can't remember the name of it now, but there were other dinosaurs that had 5 horns sticking out of their face. So I can, and by the way, radiation affects bones more than anything else, and so I can see that during these magnetic reversals, when the cosmic rays, radiation, attack the the entire Earth, that I can see that it would change the bone structure. You'd have more bones or less. You'd have horns or not horns, and I'd like to see more study on this and see how often magnetic reversals do seem to occur in sync with evolution.
Now, how would you, I mean, this is very difficult to know, but what we've heard so far is, of course, that cosmic radiation is very dangerous. It would kill us, if we're exposed to it, etc. But at this stage, we've done perhaps comparisons with, man-made, well, there's natural radiation from the Earth as well, but, through our, nuclear, fission and division and all that stuff, we have created radiation, and that's what we know is very dangerous to us. Maybe the cosmic radiation is of a different, I don't know how to call it, but more benevolent in that regard, that it's not one that would kill us instantly in the way that we think of it. Have you thought anything about that? That might be a difference between the different types of radiation?
Could be. I don't know the answer to that. Another thing, though, I should mention, though, that seems to have happened during magnetic reversals, and again, I'm out there, but not totally out there, is there's something called the Carolina Bays, which I had not heard of before I started studying this, but in the southeastern United States, there are holes in the ground, and when I'm talking about holes in the ground, these are holes that are as much as 6 miles across. So what would how many ever kilometers that would be across? And they're only like 20 to 30 feet deep. But across the southeastern United States, they're called Carolina Bays. They look like swamps. If you're down on the ground, they just look like swamps. But in the 1930s, when aerial photography started to take place, the photographers were looking down and they realized that these were elongated holes. All of them were elongated, and some of them actually overlapped each other. And as they calculated out, they called them Carolina Bays because there's Carolina Bay trees. That's the kind of tree that's growing in these swamps. But they began to realize that there are more than 2 million Carolina Bays in the United States, and that these were all created at approximately the same time at about 11,500 years ago. Mm. Now, and they were blasted into the ground, by explosions in the sky.
Yeah.
And so I'm saying that we'll also be having, if you were standing at ground zero, then forget it. You're going to be pulverized. And they've also found now people have sent me information on that they found Carolina Bays on Google Earth. They still show that they're there in Australia, in northern Russia, in Alaska. They found these what are called Carolina Bays. There's a whole there's a book. I can't remember the name of it. A cycle of cosmic catastrophes.
Right.
But there's a physicist and people and geologists in the United States that got together and wrote this book, and they think that the Carolina Bays were created by an exploding comet, which to me, they blame all things on comets. They like to blame the dinosaur extinction on a meteor, rather, and so now some of them are trying to blame these Carolina Bays on exploding meteor. I think we'll eventually find out that those Carolina Bays were created by explosions in the sky, created by the magnetic reversal.
Like a electricity plasma.
It's just too close. I don't know how that would happen. Yeah. I really don't know. But it just, the carbon dating shows that these explosions took place about 11,500 years ago. And then we've got the Gothenburg magnetic reversal 11,500 years ago. To me, this is way too coincidental.
Right.
That it has to be related. I don't know how that would happen. Part of it is I look at, I compare it to Tunguska, And you probably heard about the
Sure.
explosion in Tunguska back in, what was it, 1905, something like that.
Something
But
like that. Yeah.
that explosion, they figure, was 5 miles high in the sky. They don't exactly know what caused it. Some people say, again, it was a comet exploding or a meteor exploding. But it's interesting that they also found a big fluctuation in the Earth's magnetic field right at that same time. Did that fluctuation cause the explosion, or did the explosion cause the fluctuation? I don't know.
Right.
But what I'm proposing is that we're going to be looking at hundreds of thousands of Tunguska-like explosions. That explosion, it was 5 miles in the sky, and yet it knocked down 3-foot diameter trees for miles and miles. Just wiped them out. And I think that's what we'll be looking at, is hundreds of thousands of Tunguska-like explosions in the sky. At the same time, and here I'm going out again, but at the same time, I think carbon is created in the sky, is because at this 11,500 year time period when the Carolina Bays were formed, they have found areas where there's a foot of carbon. They have discovered mammoth bones, mammoth bodies that are covered with a layer of carbon. They have discovered ancient Indian artifacts that exist under that layer of carbon, and above that layer of carbon, the artifacts disappear. And it ties back in with the dinosaur extinction. I took a trip to Drumheller, Alberta, many years ago. In Drumheller, Alberta, they have the Royal Tyrrell Museum of Paleontology. It's the biggest paleontological collection of dinosaurs anywhere in the world. And when you drive into Drumheller, you can look up on the side of the hill, and there's a layer of black, about a foot thick, a layer of coal. And below that layer of coal, there are dinosaur bones, dinosaur remains everywhere. Above that layer of coal, no dinosaur bones. So something ties all of this carbon, all of this with extinctions, something ties it all together.
Huh. Now, wonder what kind of evolutionary changes we've gone through in the past that is tied to this, 11,500 year cycle. Have you done any more correlation there? Because it seems as well, same thing there really, that we have different species of humans coming and going pretty much. How much does it match up with this cycle?
Well, as near as I can tell, and again, it's tough because the geological record is tough to fathom, but as near as I can tell, the Neanderthal appeared on Earth about 115,000 years ago at the Blake magnetic reversal, and then disappeared about 33,500 years ago at the Lake Mungo magnetic reversal. There's many various animals that do show up in the record with magnetic reversals of 2 million years ago, huge extinction then, and then new animals appeared. There's a lot more study to be done, because when you're digging through the geologic record, it's very hard to pinpoint exactly when a magnetic reversal occurred. And for instance, when scientists are just for the last 150,000 years, they digging through and they find a magnetic reversal, and then thinking, oh, well, that couldn't have happened then, so they move it to a different place. And I think there's a lot more to be learned. A lot more to be learned there.
Yeah, definitely. Now, is there any possibility, do you think, as well, that on top of this we have not only the cosmic radiation that adds to it, but the very idea as well that if circumstances are different on the planet, we the species that are left are forced to adjust to those circumstances. So you have yet another layer of a mutation that it's occurring because of the properties of their environment.
Oh, I would think so too, that they'd have to adjust. By the way, going back to the dinosaur extinction, many, many, many dinosaur bones are found buried in the layer of radioactive material. And many, many, many dinosaur bones are found in coal. There's a coal mine in Bernissart, Germany, I think, where they, in this coal mine, they were digging down into the coal mine and they discovered dinosaur bones. And then, and they were all together. They were not. They were articulated, meaning that they were together, not spread around, as if the dinosaurs had been trapped in the coal. They dug down another 11 stories, another 110 feet, and there were still dinosaur bones, and they're still trapped in that coal. They have found, in many coal mines, they found dinosaur footprints embedded in the coal. Now, how do you embed dinosaur footprints in coal unless that coal had not yet hardened? So, and again, I don't know the answer. It's just very interesting that so many dinosaur bones have been related to radioactivity. And there's also a lot of radioactivity in coal. So again, I'm kind of hanging out there, but I think that coal and that, or at least the carbon, is created in the sky during magnetic reversals.
All right, interesting.
And rains down on our heads. Yes.
Huh. Well, so if you allow me to ask you about speculation here for a little bit more, what do you think that we are in for when it comes to changes, maybe not only of the human species, but all of it pretty much at this stage? That if we had something like this occurring, we would have, as we've seen in the past, then of course a massive die-off, but then a certain portion that managed to survive takes off in a new direction. Do you think we would mutate into something even more, I don't know what to call it, but advanced, something that is a little bit an upgrade, if you will, as we've seen? That seems to be the case in the record so far, that we go through these changes, we adapt to the new circumstances, and we slowly kind of develop, our art, our culture, technology, and everything else. Is that part of this too, do you think?
I think it's possible, but I think it's also possible that we regress instead of advance. So, in evolution, it's kind of like the meanest are the ones that survive, and they really are. Unfortunately, they're the ones that survive, and I don't know if we had mutations that created some meaner, angrier people that were less advanced, they still might end up being the evolutionary winners. It's that's kind of scary.
In other words, all those evil people in their bunkers with their food and weapons, those are the ones who's going to survive.
Yes, they might be the ones who survive. I don't know. By the way, I don't have a bunker. I'm figuring that if that happens, I'm probably not going to make it.
Right.
The odds would be against it. Now, the other thing that can be said is that studies of children in the womb in Nagasaki, where the big World War II atomic explosions, but children in the womb, or babies in the womb, were much more susceptible to radiation than to others. So that would probably be where it comes from. And how does it create a new species? Well, what I'm thinking is that it would probably be brothers and sisters born of the same womb at the same time, because otherwise, who's going to be there to mate with that new species? So I'm guessing that it could be just an Adam and Eve type thing from the same womb that end up creating that new species. And with the billions of people on this earth, I would say that probably most of the mutations would be those hopeful monsters that would not make it. But with all of the billions of people, there would probably be a few hopeful new monsters that would make it. Some of them might be smarter, but some of them might not be.
Right. Well, if we think about all the nuclear power plants in the world that during an episode like this would no longer be able to cool their plants, etc., then the picture becomes vastly different, of course, which is kind of a bummer.
That's true. Unfortunately, that's true.
Yeah, that might add
So
to it.
I don't know what will happen, but I talk about those. And, oh, by the way, if we could go back to the ice ages just a second, there's
Yeah.
also another, because it has to do with cycle. There's also another cycle called orbital stretch. That our orbit around the sun is not a perfect circle. A lot of us think it is, probably, but our orbit around the sun is actually elliptical. And not only is it elliptical, but that elliptical shape changes from an ellipse to near a perfect circle and back to an ellipse again. So sometimes the Earth is further away from the sun than it is at other times. Well, that cycle of orbital stretch, that change in the size of the elliptical circle, or the ellipse, that goes from the ellipse back to the circle, back to the ellipse, approximately every 105,000 years. And every 105,000 years, we have a major ice age. Those are the really major ones. Now, the one 11,500 years ago, we may not call it major, but 40% of the animals that weighed over 100 pounds went extinct. To me, that's pretty darn major too. But
Yeah.
the really major ones every 105,000 years, well, we are due for that one right now also. So we've got the 360-year mini ice age cycle that is due right now. We have the 11,500-year ice age cycle, the larger one, that is due right now. And then we have the 105,000 orbital stretch ice age cycle, the huge one, that is due right now. So with all of those things staring in the face, I don't see any choice but what we're going to go into an ice age.
Wow, that's pretty interesting. So all those combined, of course, is the reason why you also say that we are in for the big one again, the big ice age, not just a mini one. I guess again, it would. How would you see the onset to that? Would it just? We talked about this briefly a bit, just as a way to kind of wrap things up here. We would see things coming on a little bit every year, and the winters would be longer and more build-up precipitation, and that's really how it would be, right? Because it wouldn't potentially happen overnight like that. It when it comes to the ice age, it is a slow build-up. It seems like, correct?
No, actually, I mean that is again, we're talking consensus that a lot of scientists say that, but since the 1990s, that consensus is changing. There was a group in the 1990s, late 1980s, GRIP, Greenland Ice Core Project. And what they did is they drilled holes into the ice in central Greenland. They were able to drill down 2 miles, and they were able to pull up ice cores from the last 250,000 years. And what they discovered, they were absolutely amazed. They did not believe this at first. They did not publish it at first, but finally, it just coming up, they discovered that every single ice age in the last 250,000 years, every ice age in the last 250,000 years began in less than 20 years. And when I say began, I'll mention the Eemian period. The Eemian period ended 115,000 years ago. The Eemian period was an 11,000-year period that was even warmer than today. Our climate descended from that warmth, even warmer than today, into full-blown glacial severity in less than 20 years.
Yeah.
And every ice age in the last 250,000 years began in less than 20 years, sometimes in only 3 years. So that's why I'm worried. When this happens, it is going to happen in a hurry.
Well, it's a good point. Yeah, you brought that up, and exactly, I remember now. There's this record of basically they're finding these flash frozen animals in Greenland. They're like, it seems like something that happened in like within an hour, pretty much. They had green vegetation in their mouths, even.
Well, yeah, I do write about that, and not by fire, but by ice. I don't know that they were flash frozen, but they do find, for instance, mammoths that are still standing up, that do have fresh food in their bellies, and that which means that it had to have been warm enough and the grass was growing there, and that they were grazing, and all of a sudden a snow blitz came along essentially and buried them and left them buried for 11,500 years, and now some of them are starting to to show up in the ice. But yes, it does happen that quickly. And they're neat, by the way. If you freeze something slowly, it changes the cellular structure, but their meat is often still dark red and fresh looking, and when they feed it to the dogs love it. So, but yes, it happens.
Exactly, that's what they're starting to interject. But exactly, you're right, because they found actually woolly mammoths with blood, flow within them, so that they've actually been trying to. This is why they tried to clone some of them, actually, because it's so pristine, the material.
Yes, and so that's the big reason why I get worried. And the other thing is that when they uncover these mammoths, very often the ice around them is interspersed with lots of volcanic ash. So it's another indication that volcanoes are going off at the same time. I look at Yellowstone, super volcano. If we, and there's like 30 other super volcanoes around the world. I think there's one in the Eiffel Fields in Germany, and there's others. But if we have a super volcano go off, I think we'll be in an ice age within months. Not even 20 years, within months. So again, I'd say that the one way to keep track is to watch volcanic activity, because if we have something like a supervolcano, then you've got all that ash rising into the sky, and at the same time, probably those underwater volcanoes are exploding, and so you're going to have more and more moisture rising into skies that are colder and colder, and you're going to be looking at those huge snowstorms that are just going to bury us.
Yeah.
You put that together with the Carolina Bays and the magnetic reversal, and I hope it doesn't happen in our lifetimes.
Well, exactly. I mean, it's not encouraging, but the fact is that we are along for the ride, and Mother Nature, she has her course in that regard. I mean, we'll see if we can manage to adapt to the circumstances, if that's indeed where we're going, and maybe not. Maybe this will be the incentive for us to try to advance a little bit more when it comes to space travel and getting out there into some of the other places. I mean, it could come with a lot of positive side issues as well. So I mean, I don't think it's the end of things necessarily, but it would definitely be very difficult and changes to adapt to, for sure.
Yes, yeah, absolutely. But yeah, and I think at least if we have our eyes open and understand that we might have to adapt, why I don't know how to plan for it. But that if it happens, there was a book out here a while ago called 1 Second After, which was talking about if a huge EMP occurred on the Earth, where it wiped out all of the electricity, like you were talking about, and even wiped out the magnetos on cars, so cars would no longer run.
Yeah.
I would advise anybody, if they can find a copy of that book. I don't sell it, but if you can find a used copy of it, read it. 1 Second After, and it gives a lot of good ideas of how one might survive such circumstances.
All right. Well, very good. Yeah. Well, we'll link that up as well. And the first step in all of this is, of course, to recognizing and thinking about the possibilities of what could be going on. That's a major step right there. So it doesn't sneak up on you and just surprise you. So thank you again, Robert, for coming back with us, talking about this and helping us to